Thank you. I will check it out, I guess, after the stream. But yeah, so what I was talking about is that yesterday we got this or else macro down that like automates else branches, right? And today I'm gonna try to do another kind of variation of that, is or return, right? So what it's needed for is, you know, situations like, you know, you want to like parse like something and would like, you know, return something like parsed result and maybe like okay whether it succeeded, or it might return multiple things, you know, like parsed like cursor, so maybe it's like reentrant and then okay, which is like, you know, something like cursor, I don't know, like something like that, right? And then you would do something like it will accept something like raw, and then it would like for something, right? Like and usually would do like if not like parse like chunk, right? And then you would do like return, I don't know, like empty string like -1 and false, right? Stuff like that. Like else you would proceed. And then like you would parse, you would have like a waterfall of parsing, and you would have to return this every time something goes wrong, or maybe some intermediate values, right? Maybe like you would get into a branch where like your parsed is, you know, parsed like d8, and then like your cursor is like 5, right? And then you like if like not parse like another chunk, right? Then you would want to return like whatever you have at this point. So you would like return parsed like cursor and like okay, right? And writing a lot of these might become tedious, and that's why programming languages usually have some kind of a shortcut for that. Yeah, like question mark and Rust, or return in Odin, probably something else in other languages, right? So Jai doesn't have anything like that. In Jai, you can do like, you can define return variables like that, so you can assign them names, right? And if you do like return, I think that should just return those. This should like compile, I think. Is it not unable to open? What did I do? Oh, or return that Jai, right? Expected. Oh, I screwed up the syntax here. And not enough values. How do you use it? I remember there was like, I think some way to just maybe return. Let me hit the how to like return calling procedures, I think, like that. Wasn't it somewhere here? I thought there was like a shortcut for returning stuff. Not like that. Oh yeah, here. here, yeah, here it is. Oh, you can't return them because they don't have default value. Hidden things. So yeah, you need to give them default values, right? So parsed like equals something like that, -1, and now you can return. Yeah, now I can return. So yeah, that's the rule. That's the rule. I think I want a bit more gain on my microphone, right? Don't I? Where do I get it? 1 second. I think like that. Let me know if that's too loud. Hey Pika, what's up, what's up? Like this music playlist, it's very like inconsistent when it comes to the volume of music. But yeah, so yeah, and I want to kind of automate this kind of return depending on their kind of intermediate values, right? So what I want to do is like something here, right? We'll call or return and then if like the result of the inner call is false or falsy, then I will just return whatever here. So the macro will generate return function for the call side. And let me check if that's how Odin's or return works, because I don't actually know. Yeah, let me bring it up so we can read it. Okay. So or return operator. The concept of or return will work by popping off the AND value in multiple valued expression and checking whether it was nil or it was false. And if so, set the AND return value, send the AND return value to value if possible. If the procedure only has one return value, it will do a simple return. If the procedure had multiple return values, or return will require that all parameters be named so that the AND value could be assigned to by name, and then an empty return could be called. That's hard to understand. Let's see the example. We have an enum, it's like an error enum, caller 1 that returns an error, caller 2 that returns int and error, caller 3 that returns double int and error. Now foo1 proc that returns an error. This can be a common idiom. Caller 2, if error not equals nil, return error. Okay. I updated it today. I updated it today. I don't really play much Hollow Knight now, right? So it kind of doesn't make sense. I guess. Thank you, Earl. It's like from yesterday's stream. The above idiom can be transmitted into following equals caller 2 or return, right? So n1 would be assigned, or the function will be returned, right? So here it has two values. If we return like, if this is like 0, right? Not nil or not false. Not equals nil. Huh. It's kind of a little bit different, right? So it checks if not equal nil, right? It was not nil or false. So not nil or false is kind of important. So it just makes this enum idiom possible. So I'm not gonna do not nil or false. I will just rely on false for now. This is like it's like not very obvious to me. But yeah. So color 1 or return. Color 1, yeah, or return. So it checks if this is not nil, otherwise then it returns. And color 3, let's see what happens in color 3. N0, N1. So it gets these two and it pops off the tail end, right? And here are named. So Odin also has named return values, as you can see. As you can see, it is more common that your procedure returns multiple values if or return is used within a procedure. Right. Say color 2 return. Yeah, so you see, and then or return. And here or return, I guess it will just return default values here. Oh, I know what it does. It will push error up the stack. So in a procedure like this color, its end value has to return the same as here, so that it, so that it propagates the error. Like the entire, I guess, point of this is not just automating early returns, is also to propagate errors. I don't know if I want to enforce that. You know what I mean? It also has a combination to defer. Transformed into following x is int x error, like this, return. Wait. If or return is used within a procedure that returns multiple values, 2+, then all the returned values must be named so that bare return statement can be used. This is limitation of Odin, because Odin doesn't have metaprogramming, because it needs to know how to assign variables. In Jai, we don't really care. We can just construct this return based on the types. So we don't need this kind of limitation, right? Because we don't need to put like bare return. We can just construct return with whatever we need. Right, so in this case, what return will do? It would return n, which is like what, 0, and error, which will be like none, which will be like error, which will be error here, right? Like n. Yeah, and what's that? Y, color 2, or return, also returns like 0 here and error whatever returns here. And here color 1 We'll just propagate. We'll just propagate the error. If error color yes, I see. If using non-bear return statement is required, setting the return values using the normal idiom is a better choice. Yeah. If the other return values need to be set depending on what the end value is, if error not equals nil, n minus 1 return. Wait, so we end 23 return, and then we kind of reset the end here. A return also supports the OK semantic common in Odin code. Note an error is indicated by OK being false. Color for a return. Yeah, okay. So some of this I like, some of it I don't like. I don't like requiring naming. It's like, it's not a big deal, but it is an inconvenience. Also, I don't like this. Not nil or false. We start with only false. So, what's the start, I guess? Our return will accept some kind of code. That's an obvious thing. Then multiple falsy return, multiple falsy values. What do you mean? So not nil and false. That's what you mean. Yeah. We will try to avoid it for now. So I'm gonna call parsed foo, and I'm gonna let's do this kind of similar test case as an Odin. So we will have like multiple colors. Like first, like just the similar kind of. Let me just copy that and that, just so we have test cases. Color 1, like as bool. Return like that. Color 2. Return int and bool, and return this and true. Then that int bool will return 1 2 3 1 2 3, also true. Now foo will return bool. This can be a common idiom in many code bases. OK equals color 2. Like I don't need this, I just need this. But in this case, n1 like or return, right? That will be our syntax. Shit. Yeah, this will be our syntax. Velika beba. Nice nickname. Are you from like Serbia or Croatia, or from like Bosnia? Because Velika beba means like big baby. Croatia, yeah. Nice. I used a short circuit macro thing a while back when writing parser might be of use. Yeah, let me open it on the site. Short circuit, yeah, on fail code. You have like you did even like more generic stuff, right? Because you have a callback on fail. Try, if not condition, throw. You have also throw. Damn. Yeah, so it's short circuit. It's a little bit like or else that we had before, like a little bit. Try, must be a. And yeah, and you're required to pass a code. So it's like it has slightly different semantics, but the end result is similar. Hello, Vivian Velor. Hello, hello. You're from Bulgaria. Yeah, I guess it's a Balkan stream, right? Yeah. Dobrodošli. But yeah, so I don't want actually like generic like on try, because I don't really want to write a cleanup code, but it might be a different, like it might be an interesting different macro. I actually want to just straight up return, right? So like this, n1 equals color2 or return, right? So in this case it should be just straight up n1. So let me remove this and call foo1 here. Let me do this like as usual, like import basic, import compiler, maybe I namespace the compiler, also using only print vars is import, I think like this. What else do I need? I need semicolons because Jai needs them. Let me do all that. Right? Okay. We compile. Let's start. So we're accepting the code here. And first thing what we need. So in or else we kind of enforced the procedure call, but maybe here we I think we still need to enforce the procedure call, because right here we could accept any kind of expression via code, right? We could do something like code a like equals b, right? Something like that. And if it's like bool, if it's false, we just return. But this is kind of meaningless in my opinion, because if you want to do like an arbitrary expression that would return something, it's at this point it's just better to write a simple if. So I think this makes sense when you call something. So that's why I'm gonna assume for now. And actually in we already have all of the required work kind of done here. Right, so what I want to do is to copy this modify on the macro. The Emacs is a bit picky about the indentation, like that. And it's not the, let me actually call it. Actually, maybe just call it code. Hey man, Ezekiel, hello. Yeah, new PFP. From yesterday's stream, welcome. If not procedure call or return macro only supports procedure calls, then we do get the call, get the proc expr. If it's not procedure header, unexpected resolved, blah blah blah. We get the procedure header, after which we get the return values, and then we need to remove this because we will support however many, right? Right. What's next? We don't need this, we don't need this. We don't need anything like that. Yeah, just return true here. Actually, our macro itself, it's not gonna return anything because it is going to insert code to the color scope. What I want to do here, I also want to accept the color code. I think that's what we will need. And so here inside of an actual macro, we need, so what we need to do is we need to get return values of the procedure that calls to this macro. So not the code, not the procedure call that is passed here, right? But this one, right? And so color code, for this we need to inspect color code. A color code is code, so we need to do, it has to be run. It has to be like inside of run. Color root expressions equals get nodes and color code, and then let's print vars. So yeah, let's start. Invalid top level directive modify what? Oh yeah. No? Attempt to use modify on a non-polymorphic. Huh. So I guess I can't use modify here because it's not polymorphic. So I guess I need, I can, this will work, right? Yeah, I can just mark this as a constant and then I can use modify. Like, this is actually not a very intuitive life hack, right? So I put the code here, like I baked in the code as a constant, which made this whole thing polymorphic, which in turn kind of make this possible. I think I don't need it here. Right, so let me actually I will probably still need to do that because I want proper compile errors in this case, and I know that if I do them in the macro, then it's kind of... Okay, let's try. Let me try to do it here. Let me comment this out for now. Move everything here. Root expressions, color root color expressions. No, let's put it here. like that. We compile, attempt to open a subblock on a like that. Unexpected end of input in the code block. Wait, what? Wait. Oh, I forgot to comment this out. Too many return values. Wanted 0, got 2. Where is return? Oh, it's not return false because this needs to be an assert. And then like that. Right. Then this also needs to be an assert. And then, yeah, that's it. Compiler report and pass a caller location to a nicer error message. Maybe I actually, that's what I did. This is, I didn't do exactly that, but I just formatted caller location manually and to get this. But it was slightly worse because the actual error message was second in the call stack, not the last one. Right? So you can see that like there is no main, right? Like you can see the error in the macro, but you like can't see where it comes from. I guess in this particular case it doesn't make any sense, but yeah. Oh, okay, yeah. Like this, right? So you can see assertion failed or return macro only support procedure calls. And you can see it gets fired in the assert helper here, right? But you don't see where it got called. Like where did it get called? You don't know. And so for this, I need to like parse caller code. I need to like compile a report, but it will be like second in the stack trace, not the first one. And that's why I kind of moved it to modify in the previous macro. By the way, why doesn't it work? Is procedure call? What do you not like? Oh. Those should be reversed. Yeah. Yes, so I kind of have to so I have to move it back to modify because modify gives better error messages, which kind of sucks. Yeah. So yeah, to kind of again to reiterate, right? If I pass like incorrect parameter to the macro, I don't see the call side, right? Report. Let me remind what compiler report does. Yeah, make location. Let me do it. So I would, instead of doing assert, I would do it like I did it here. So I would do it. Oh fuck! What am I doing? I'm blanking on like Vim hotkeys. let me like fail it, and I will do compiler report boo and make location. Like get nodes, something like this. Oh, compiler report is probably also namespaced. Okay, too many return values. Oh, it's because error boo, right? Okay, maybe that's good. Actually, I can maybe do compiler report instead of assertions. How about that? So you see, I like so I get this kind of, I get the call side, return macros only support procedure calls, but it would be good if I also got this. Okay, let's experiment with that. Let's remove assertions, and here instead of assertion we do if proc expr kind not equal procedure header, like that. Let's experiment with this kind of errors for now, and then we'll see. Maybe let me like format it slightly nicer. I think this, yeah, works. All right. So what are we doing now? We need to get, well, first we need to check return value of an actual call. So we need to parse the procedure call. We need to get all of its return values, all of them, like this. Then we need to insert those return values in front of the call itself, and then we need to check the last one of them. So we already did all this work on the procedure header here, like call header, no, code, what do I call it? Code proc header. Oh, my chat died. Okay. Yeah. Code proc header. And then these return values, we need to insert all of them. We can format them into a string. We can, like previously, not previously, like yesterday we implemented first version with string interpolation, and then we switched to the code nodes. I guess we can do the same thing today. Just start with a string. So yeah, let's do it, right? Then So we do for return values. We do them like in comma separated. I guess we might first create a list and then we can join this into a builder. Right? Yeah, let's just do the simplest possible thing. How did we? Header returns type instantiation. We actually I don't even want to get type instantiation. I just literally want to show them into the code. I don't care about their types. I just literally want to do I just literally want to do this like red like that and format it with it index. Literally this, and then if it index is less than return values code, like if it's less than code -1, then we append comma space, right? Else if it like equals code -1, we append colon equals like that. Let's then print builder to string builder, and we will do print vars. We compile. Argument to for is not an array, struct, or string. What? Oh, it's not count. It's not a count. It's like this. Not code, it's count. All right. Builder to string red1 equals 2. Okay. Not like this. It should be space, space. Red1, red2, colon equals. Yep. This is correct. After this, we want to insert the actual procedure call. So, for that, what we did is so we cheated a little bit with like program print yesterday. So what we did is print expression into builder, and we print in the root, right? I think that should work. Equals color2, easy clap, right? And then we append semicolon. Yeah, just like that. Red1, red0, red1 equals color2. We also need to check on this one, right? So we do this, print to builder red index, and now we need to compose a check. So for that, we need the last return value. It's very easy to infer. So we need to append to builder the following stuff. Print to builder. If not ret percent, where percent is like return values count -1. We can actually do one based, so we don't have to do this. All right. It doesn't actually. So we can do +1 here. We can do +1 here. And we don't have to do it here. So all our +1s are contained in the same place. Does it make sense? Right? So all our off by ones are contained, so I don't have to do it here. Hope it makes sense. If not like that, then we actually need to backtick return of the of like this. So for now, let's just backtick this shit right here. So backtick return, right? Backtick return, semicolon, and when I insert it, it should blow up. And it's like some shit ass song. Let me switch it to something else. Where's my epic fucking PlayStation 1 music? It's never missed. Actually, you know what? No, fuck that. We're gonna listen to 4 hours of Elder Scrolls. That's better. Okay, return backtick, and then when so this we don't use for now. We just literally do insert string, and we do like here we do return builder to string baba. It compiles, but we don't call it anywhere like result1 foo. And now if we print vars result1, it should be it should be true. Is it true? Yeah, it is true. And if wait, shouldn't it like blow up or something? Oh, because it always returns true. Wait, it didn't return. Did it? If not, then return. Oh, because it's not complete. It's incomplete. If not return 2, then we need to like return the outer thing, but otherwise we need to this is actually interesting one. So we need a combination of return values and a return from the outer scope. Let me try to break it. Like, this should totally... Why doesn't it... I know why, because builder to string... Because when I call builder to string, it frees the builder, so I can't call builder to string twice. Yes, that's why. This is actually very important. I would have spent a lot of time to debug this if I didn't already know that. I mean, I would have fired the debugger. I would have instantly seen that the builder is empty. Because like if you see the signature of builder to string, like do reset equals true, right? It's like an optional parameter that, like, if do reset, it resets the builder. Yeah. And now it should blow up. Yes, yes, exactly. Type mismatch, type wanted bool, type given S64. When building return by this insert directive. And interesting that, again, I don't have a proper stack trace here. Like I have added strings here. But I don't have main. Which I think it would be nice if I had, like, here, like where it happens. But we will improve errors later. For now, I know if I remove this, it should also blow up. Right, because not enough return values. Wanted 1, got 0. Here, at least we have that. Like, right? Foo returns 1 boolean, and we try to just return nothing. So if not return 2, we need to return it. Return red, like that. Incorrect number. Oh, yeah, sorry. This needs to go twice. Yeah. If not red 2, return red true. And we need to add else branch, like else return. This is interesting, right? So this macro, you know, it might return something, it might not return something. So can we even do that somehow? Like, you know, this should get the return of the color 2, like of this. So n1 should get this integer if this succeeds, which means that macro should return something. But macro could also have multiple returns. I wonder if it's even possible to express that in Jai. Right? I don't think it's possible to express, like in polymorph, that a function can return one or two variables depending on this. Yes, exactly. No, hello. Yes, exactly this. And so I got the return part. Hey Pimpus, what's up, what's up? Yes, exactly. I would have to generate the whole macro. Yes, that's what I'm thinking about. Huh. Like, I would have a template for the macro like that. And then I would have to generate this part. Right? I would have to generate this part in an outer metaprogram. Like in a compiler event loop. But also, I wonder if this can break due to the fact that this inner signature will be the same always. So I think it will be beneficial for Jai to have a way to somehow express that a macro can return different number of return, have different amount of return values based on the on this. Yes, I know. Zeke has this, Odin has this, Rust have like a special syntax for that. Jai actually doesn't have a special syntax for that, but Jai has insane metaprogramming that lets you implement that in userspace. Actually, I know you weren't on the yesterday stream, but yesterday I implemented or else. Like I implemented or else in the similar way yesterday, and it actually worked. But or return is slightly different. You did the advent of quote in Zeke, nice. But yeah, I wonder what can we do. I mean, yeah. I know you weren't. But yeah, I did. Or I actually a minute of self pat on the back. I resurrected my old YouTube channel where I used to post like programming stuff, but I long since forgotten it. And yesterday, like, or today, I guess, I uploaded yesterday's WOD. I also gave it nice chapters and all that. So let me chill. Here's the WOD of yesterday on the channel. Yeah. So what do we do? Huh. Let me check if there it's like a possible to have that at all. Let's have a convolute situation where like I have two different macro types, one of which returns a single type and another returns the double type, and if I recompile, unable to parse, oh yeah, because return type should be here. What do you need? Oh, it's... Enable to parse the same shit here. Procedure did not match any of the possible overloads. Oh, it did not blow up. Look at this. Look at that. So let's imagine we have actually modify here. And like T1 equals Boolean, right? Like, and in this case, and in this case, where is it? Like T1, did I uncomment? It should be like that, right? Like this. Should be like this, and here, yes, correct. And here, like T1 equals int and T2 equals Boolean. Will it work? Not all control paths return value. Where? Oh, it should be returned true. I'm sorry, modify should return true or false. Okay. Procedure call matches two possible overloads. The call sites argument types are int. Huh. So it doesn't know. Okay, let me uncomment this. Maybe I can wrangle it. Like that. First return, second return. It doesn't have. So in this particular case, it only has first return, right? T equals first return type. Undeclared identifier code. Where? Line 3. It literally is. Oh yes, because I need to do it like that. Second. It worked. I like it literally worked here. So I was able to use modify to resolve the overloads on this fucking single return value. So it's literally possible. That's fucking insane. That's fucking insane. It means that we can use outer metaprogram to generate this macro. To generate this macro with however return values we have. Right? All we need to do is we need to like substitute this chunk with the amount of return values, and we need to do this basically. Assign these t's. That will be quite a task, I tell you. So what I want to do now, for now, I will just hard code it. Or wait. Yeah. Wait. Let me read the chat. Some advent of code in Zik. C might be also fun. Yeah, I agree with Pimpus. I would definitely recommend learning C. Like even if you won't end up programming in C, like just knowing it has so many benefits. Yeah, it's like knowing C is just so useful, and learning the basics of C literally takes like a day. Maybe use code type in the modify to reject based on the type of the code. Yeah. I already did that. Would be a lame metaprogramming facility that didn't let you metaprogram from your metaprogram. Yeah, I mean, like, here's metaprogramming, right? So here I'm metaprogramming inline, like inside of the macro. But there is also a metaprogram that runs during the compilation, kind of like an outer compiler loop that I can hook into and get compile events as they come. You know, I can wait for type checked events, and as I'm getting them, I can accumulate them in an array, and then after all the type check is done, I can kind of resubmit more abstract syntax tree to generate these motherfuckers. So I guess that's the plan. Like, that's the yeah, that's kind of the plan. But I don't think I'm gonna do it now. Now I just want to hard code 2 of those to see if it's possible. Before I'm automating them, I want to kind of roll a couple of those by hand. Are you sure that what you're trying to do works? Because it feels to me like the problem is variable in the color scope. I can see it working if you do something like n equals color. This won't work. No, because it's not syntactically correct to do that. So you can't do this. You can't do this. Like, this is a syntax error. See, expected. You can do this. This is possible. Like, right? I mean, it yells on modify, but this isn't tactically correct, passing the code. But I want to avoid this for few reasons. Actually, 2 reasons. Reason number 1, it's more verbose, right? It's just like you get tired of doing this. And the whole kind of point of this macro is to reduce amount of manual typing. This has been reason number 1. And yes, Pimbas, it's kind of a quote operator in Lisp, but type safe. And the reason number 2 is that it means that this gets into macro too early. If I catch the code like that in the macro, color 2, if it's polymorphic, will not be resolved yet. So inside of the macro, I'm not going to get the types of return values, right? So I will have to do the entirety of this macro resolution in the compile metaprogram. You know what I mean? So I would have to do all of that somewhere like outside. In the metaprogram plugin, for example. In case of all return, maybe it's fine because, as we just figured out, I will have to do it anyway to generate this. Right, so maybe it's fine. Yes, maybe it's fine. But yeah, overall, how does n resolve when you'll have a macro that does return? So wait, let me make sure that I understand what you're saying first. How does n resolve when you have a macro that does return? So when I do this, right, without the code, when I do this without the code, the way it works is that this is a code implicitly, but it has to type check first, right? So in this case, it only has to pass syntax check. And in this case, the color 2 have to always be type checked. So by the time I get to call this macro, this entire thing is already type checked. So I can fully inspect it like in line with compiler get nodes. right? So it means that I can already do like backtick return with like this and that, because this will also be type checked by this time. So first this gets type checked, then this gets type checked, and then like macro gets type checked, and then like kind of macro gets expanded. So yeah, without passing it as a code directive, it first goes through type checking, and then it lets me insert the code. I hope it makes sense. I hope I'm correct. Second, I hope it makes sense. With N1 being assigned. Yeah, this all shit gets type checked first, then the macro gets inserted, then I get to insert the code, then that stuff gets type checked, and only then it gets assigned. That's what I think. We can actually just verify it if it works, right? So first, let me get back to this. Let me just like, yeah, I can do that. Let me uncomment this, all of these checks. First return value, second return value. Then I just get T1 is the first return value, first return type, and T2 second return type. Let me see if it still works. Undeclared identifier code, yeah, because it has to be baked. Procedure call matches to possible. Oh shit. So I can't do that. Did I get happy too soon? But why didn't it barf first? 1, 2. Why didn't it barf? Huh. Oh. Is it because of what I think it is? I think I know what I can do. I can reject this. Wait, this should have gotten rejected though. Yes, not equals 1. Yeah, because this is... Yes, fine. So, as long as I reject one of the polymorphs, it's gonna be alright. So, the second or return that returns 2 things get through, right? And actually, maybe it should return just one thing, not 2, but it doesn't matter for now. For now, what I want to do is to, if not return 2, return 2. Otherwise, otherwise, I want to return. So it's outer return, and otherwise I just want to return from the macro. Yeah, so after that I'm gonna print to builder. Let's see if I can do this. Return like, just let's hard code it. Ret 1, ret 2. Right, let me just like hard code it. Will it work? Return, and then I need to do this like that. Unable to parse an expression here. This looks like C style. What? Color 2, if not bool? What the fuck? Oh, I accidentally pasted something wrong. Alright. So it type checked. And here, result 1. Result 1. Should it be true? No, it should be... Oh. Let me print N1. N1 should work. N1 is 1, 2, 3. It worked. It worked. And if color 2 returns false, then I shouldn't get the print. I don't get the print. You see, I get early return. It literally works. Like the theory. We have a working theory, people. People in the chat, you see? We literally have it working. Now Pimpas asked for the expansion. So in Jai, you have this like added strings that literally get added to the compiler. Oh wait, no, this is the wrong one. This is from or else. Yeah, I think that's the ones. Print vars, or return. Okay, so here's the expansion. Red1, red2 equals color2. So let me open the file here. So here's the expansion, right? So color2 is here. And we generate the code just as a string. Yeah, it starts here in the string builder. We add just return1, return2 here in the loop, return values. Then like this, colon equals here as color2. Then if not return like whatever last return, we do backtick return. So backtick shows the code into the outer scope, you know, the color scope of the macro, right? Otherwise, we return from the macro, like we return here, right? Okay, so for now, all of this is hard-coded. It is hard-coded, but we have a working theory that this shit works. It like has potential to work, which is insane. So what I want to do now is, yeah, it makes sense why it returns, because by the time we get here, everything is type checked. So we can resubmit this code, which gets type checked on top of that. And it's just all kind of, woo. We're all happy. So what I want to do, I want to unhard code this. I want to insert this string based on the color root. So based on the function from the outer scope. Okay, before we do that, I want to take a small bathroom break because I drank like half a liter of water almost. So yeah, I enjoy the music. I'll be right back. I said, all right. This is epic shit. So let's I'll first change the splits, second comment this out, and this should blow up. Huh, it doesn't. Why n equals 0? Huh, interesting. I would expect this to blow up. It's like 0. Oh. Did it just return default values? So if I don't do this, if I don't insert the code, it just returns the defaults? That's kind of wild, because I would expect it to blow up with an error that, you know, not enough returns or something. Like, that's unexpected to me. Could it be a compiler bug? ret1, ret2 equals color code. Return. That's wild. Let me add notes here. Macro turns default values even if I don't turn explicitly. This is kind of weird. All right, so what I want to do is I want to like do the color code shenanigans like somewhere here. So I have the color root of the color code, and I want to, from the color code, I want to get the return function of the outer scope. Let me print the color root, which is a procedure call. And I wonder if this is a procedure call of, like, if it's this procedure call. It probably is, right? So let's see. Let me print the expression. How do I print the expression? I would have like builder to string builder and print expression to this builder 2 and color root, and then I would print vars builder to string and builder 2. Let's see, or return color 2. Yeah, so this is a color code. So this is the code that calls our macro, and I wonder if there's any way to somehow kind of go up, like, you know, like up one more. You know what I mean? That would be the kind of last step to fully prove the theory. For that, let's kind of inspect our procedure call to see what it even has. Oh, I'm sorry for the ad break. I snoozed them as hard as I can. Code procedure call. So what it has? It has a bunch of arguments. has context modifications. It has the base node, has procedure expression and result procedure expression. Macro will contain expanded code ignored on import. Let's see what the code node has. It has kind and type, and it has location. A location has an enclosing load with which is a message file. What does this message file have? Has file name, enclosing import, and from string. Doesn't look like we have everything we need though, right? So let's So maybe this is also the part that we inject from external metaprogram. Right? So basically what we need is we need something above the root. We need to go up the tree. But it doesn't look like we have it here. The code typed by the user. The expression after overload resolution polymorphism will point to a constant procedure if the procedure. So this points to the procedure header. Right. It has type info location. Like, would be cool if location maybe had like a parent code node or something. So I guess maybe we have to like switch to external metaprogram and like search for the type check here. Yeah, I'm already using color location. So I'm getting these color root. I'm getting them from the color location here. Right, already. You know, so I need to get like a color location of one step, like one more step, like one more up. I'd get from main. But like this is kind of hacky. I know what you mean. So like here I get color to. Yeah. So I would need to like somehow pass here like kind of location of foo, which is like like, so I can have the same restrictions as audience or return, right? So I can say, okay, you are like actually wait. It's actually the opposite. I need a color location type to like here. I think. Because this is an outer return. Yeah. Like this is actually fine to do. Like this is the one that is bad. Like I need to insert color kind of parameters here because that's the outer return. Right? But regardless, I need to get the type of whatever the outer type return. Maybe macro has something. So we have like a call, like if it's a macro extension block, right? Maybe this has something interesting. Will contain expanded code if this triggered a macro. Right? Maybe code, maybe this has a parent. Let's see if we can use it. Color root dot let me, what the fuck does it have? I know. Yeah. Procedure call something 0. Wait, does it not have it? Let me format the struct differently. Procedure call. Oh, I need to cast it. Color root, compiler get notes, color code, color call equals cast to compiler code procedure call color root, and then wait, what? To parse expression here, this looks like please? Yes. Wait, what? What's wrong? Oh. Okay. Macro, yes, we have macro expansion block. But you need to have a place where you define what makes sense to return. So there are two places where we return, right? First, something that we return from color to, and what we return from color to gets placed here. This would just return from the macro. And now we're wrestling with this, like what to return from the outer function, from the outer procedure. Like now we wrestle with this. So this is easy. We just get return times from color to and return them from the macro. Where do you get what makes sense to return? Yes, I'm working on that. So my current theory is that maybe macro expansion parent block has, should it be true or false? This is a good question. So the way Odin works is it actually requires it to be named like that, right? And then I guess it internally takes those and returns them, whatever they're set to. Maybe that's why it requires them to be named, right? Like in my case, in our case, we could just return, we can return defaults. Maybe this. But like, okay, like we kind of probably want to support maybe both. Huh. Like, this is an interesting dilemma, right? Like which way we want to, we can do this. Like you weren't here at the start of the stream, so the way I justified kind of this situation is, what if you, for example, parse something and your parsing is multi-step and these like values keep constantly changing, but then at a certain point you want to abort and you want to return them at whichever state they have now. Like, if to do it as you proposed by passing the value, you kind of require like more typing, and kind of like the whole idea of this macro is to reduce amount of typing, right? So I guess it makes like the more magic it is, the more it kind of makes sense. Okay, so probably we will, so I guess like now yeah. And so actually now I understand why Odin requires them to be named, right? After I went through the process of re-implementing it myself, because at the start of the stream, I said that it doesn't make sense to me that Odin requires them to be named. Like, I said that we can probably lift this restriction. And while true we can just, return default values, right? Or we can just say, okay, if it's like return value is bool, we just return false. This is easy. But what if there are like multiple return values, right? Then we want to return something. And now it makes sense that for procedures that return multiple values, Odin actually requires them to be named, right? I mean, in this case, we can do magic. We can do this. We can see, okay, if there's like a single return value, if it is a Boolean, return false. We can do that, and it probably makes sense because or return literally means we want to like bubble this shit, right? So let's do that. But then we will gonna have like full second that have multiple returns, and we'll probably tackle that one. I don't know for how long I can go. It's like 1 a.m. for me, but for now I'm kind of fine. So yeah, let me try to get the parent block. I mean, I still don't know if it's possible to do because I need to get this macro expansion block. like I assume it should be, where's the color call? Yeah, here it is. Color loot, color call. I assume this macro expansion block should be always set because we're in a macro. It doesn't have a parent. Fuck me. It does not have a parent. But it has onion statement. Like this one, the first statement from here. Oof. Jai has 0 value. It does. It does. Yeah, we have 0 value. Like 0 on initialization is one of the primarily like design decision in Jai. So each value has a useful default. Like if you define default boolean, it's gonna be false. If you define default integer, it's gonna be 0. You know, we have like if you define default string, it's like just an empty string. So it is possible. We can do that. Like we can totally do that. So we can, you know, if we can get here, we can return multiple values. We can return defaults if they're not named, and if they are named, we can return them, right? So we can support both ways, kind of both ways, I guess. But first, we need to be able to actually get there. So let me poke at this macro expansion block a bit more to see what interesting does it have. Macro expansion block, it has the owning statement. An owning statement is a declaration. Yeah. And I assume that this kind of declaration is actually like this one. Like this one. Maybe? It's either this one or this one. Let me check which. Like this. Right, and I want to print that like that. Not the color root, but owning statement. Where is it? What the fuck? T1 is S64? Oh shit, it's this one. Why the fuck onion statement is this? I know why, because it is a macro expansion. So this is what it expands to. Because it defines those overrides. It starts with defining the types. Right, so if I print those expressions one by one, so this macro expansion block, it has statements, and if I print those statements, right, so let's do this. Like for statements, print expression it. So T1 S62, T2 bool, right? And then code equals code color2, I need to print expression and then set fucking new line. So I need to do this and then append builder like new line. So it's like a bit easier to read. So, oh, wait, does it not? Why didn't it? That's weird. But yeah, anyway, so it says a bunch of stuff. Color code is code. Then it's like or return. Yeah, so these types, so this like type declaration, they get inserted before the macro. They come from modify actually, right? So this color2, color code is code of, yeah, it literally just passes the code like that. Yikes. I see. So what else can I poke into? I don't have a parent defined. So I guess this means that I have to go to the outer metaprogram, and I have to probably modify this code somehow so it's like all magic. So, you know, maybe actually what I do is like I turn this form, where is it? So I turn this form into the form that Nuno proposed, you know, into this, right? So my metaprogram will take this statement, that the user types, and it will rewrite it into this statement. And if we have this, then it will rewrite it into this. Right? So yes, that's gonna be the logic. Because I don't see a way to escape this code block. Like this is so close, right? Like this is literally close. Like if only this somehow like had like this set. An onion, yeah, an onion statement is like this one. And then you make another metaprogram that rewrites or return X default across the whole function at a time. Yeah. I mean, I was just speaking about that. I was just talking about that. Yeah. I guess it needs to be. Yeah. So that metaprogram, it will need to first generate multiple of those, right? Depending on the amount of returned from here. So it needs to do those. And it also needs to like get defaults here. So it's a I wanted to say it is a multiple, but actually not. It would just be like defaults, right? It's gonna be like code. It's gonna be like just this, right? right? So it's gonna be just like this. And like this, like these codes will just get inserted by the metaprogram, because it could be of different types. Oof. Oofta. This is like mind-bending. That's why I kind of like metaprogramming. It stretches your brain. 1 second. Somebody fucking messaged me at 1 a.m. Okay. I need to send something. Okay. Done and done. It's how you end up like Gorb. True. How super villains are created. Yeah, they do too much Lisp. All right. So, okay, let me just like poke at this macro couple more seconds. I already lost hope that I can do this from within the macro. I'm like pretty sure I will have to go to the build file, but let me just poke at it like a minute or a couple minutes more. It's here, yes. Let me move that, uncomment this. Okay, so members, I already tried to print this, and statements. What members are? Actually it changed because members and statements seems to follow each other, not counting the very... Okay, there's one more statement than there's members. Let me inspect the code blocks. Code block, right? So it has this. Has block flag belongs to the struct. It has members. Members is code scope entry. Oh. Entries, and those are code nodes. This will be in my parent block. It doesn't get set the parent block. Maybe actually the fact that it doesn't get set the parent block, this is like, maybe this is a bug, like who knows, who the fuck knows. Because it would be cool if I just, okay, I saw the parent block and the parent block just happens to be an enclosing function, an enclosing procedure. Also, let's see what code scope entries, it just has name. Oh, import target? This is never set or read. What? I can't because the parent is, because this parent is null. So let me demonstrate it. Right, the parent is null. There's no parent. So I would expect it maybe to get set, but for some reason it's not. Let me put it here. Notes, right? Note number 1. Right. Note number 2. Block doesn't have a parent when it's a macro expansion block of a caller codes procedure call. Is it a bug? Yes, it's either like some weird semantics where, you know, maybe like to save on the memory, it doesn't set the parent, or maybe it's a compiler bug. So let me, because I mean, it's definitely, it has to be present during the compilation. But maybe then it gets like removed, you know, in some like memory saving attempt. So yeah. Macro expansion block that parent is null for some reason. C notes. Just so I don't forget when I write an email to John. Belongs to struct members. Oh, I wanted to see if member has something interesting. Members 0. Multi-person. It's that. It's a declaration. Ah, yeah. Okay. It doesn't have an import target end, but all right, I see. What code declaration has? Code declaration. Right. It has a type instantiation, so it has A, it has B, it has alignment expression. Whatever it is. What is an alignment expression? Decl. It's a cast to code declaration, and then we will print vars of decl. Alignment expression is null. It is a constant. It has an expression. It doesn't have type instantiation yet because the expression is just a code node, and this code node doesn't have. It has location, and like so locate. This one might be interesting, like right, because like location. Does that mean okay? Location has a message file, but it just has a file name. It doesn't have like anything. Also, I wonder like what type info has. Maybe type info has parent somehow, but I. So you know what? So I just thought about something. So we have a stuff that's called type info. Right, type info is in preload, and this is a struct that contains type info tag and runtime size. Right, and based on the type info tag, you would cast it to this shit. So in this case, it is a type info integer. Oh yeah, this is what I was thinking about. Type info procedure. Maybe it has something like, you know, has something about its location. Procedure flags, argument types, return types. What flags does it have? It's literally here. I'm an idiot. Type info struct. It has a polymorph and oh yeah. So no, I remember like shit had memory offset or something like that. Oh, it has offset in bytes for struct members relative to the base struct. And it has offset into constant storage too, so it's not the same. I was thinking that okay, if maybe all type infos had like an offset, then maybe we could have like a parent function, parent procedure by its offset too. You know what I mean? Maybe there's some hacky way to do that, but I guess not. Source code range. What the fuck is this? Source code location. What the fuck is source code range for? Nothing uses it. It's probably some like internal data structure that gets exposed for some reason. Okay. Okay, I guess it is time to like give up and go to the build file. Where we were, where? Yeah, it's where we take the W and write a node. Okay, like in general, I wanted to get from macros color code to the outer procedure to grab its return arguments. So I don't forget why I did it at all. Let's see some of these procedures that we have here. Maybe it has something interesting, like get file name, get base name and path, make location. Oh, here's the source code location. Here's where it's used. Yeah, okay, it's used in a bunch of, I just grabbed for it incorrectly. All right. Is subclass of make string literal, make integer literal, set optimization, add segments, name of workspace, provided import name, provided import remap import, get set, get type table. This is for workspace. Runtime info, type table. We get a type table, but it's probably like blah, blah, blah. Type info flags, get compiler code. Get root type. What's that? What the fuck is get root type status? Success, input code is null, corrupted, not typed. Huh. But it won't help. What won't help either. Set workspace status. Get version compiler report. Modify procedure. This is like what we're gonna use. Right. Operator to string. Okay, yeah. Nothing interesting here. All right, I'm gonna ask about this. Let's. It's almost 1:30. I guess I'll give myself like 30 to 40 minutes, and then if I'm like totally cooked, I'll just like plug my socials, and yeah, go to rest. Okay, let's go to the build file. This should be at least a little bit interesting. So I have built a Jai. It's like cookie like cutters like build file, and I guess I want to add or else here, and it has a compiler message loop and compiler intercept, and it has like this like message loop that is completely like unfilled. Let me first change the compile so it like builds build the Jai, and yeah, build the Jai, unable to open file or else. What? Oh, it should add or return. It should first do this or return, and then executable name or return. Recompile. Okay, it works. It works. it is working. Now, here's the message loop of the compiler. Here we need to wait for the type checked messages, right? And type check message, here's, let me do that. Message type checked contains, where's declaration here? It contains a bunch of stuff, like, so this message first, it contains the declarations that got type checked, procedure headers, procedure bodies, structs, like whatever others, and all. So just a flat array of all. These are just like for convenience. There's a huge comment explaining all that, but TLDR is that, you know, it's just like, so you can differentiate it by type. So you don't have to, you know, iterate over all and like assert on the type. It's just for my convenience. What do we need here? Right? So I imagine we get procedure header, right? So we get procedure header that is foo1. After that, we get a message of procedure body. Inside of this procedure body, we wait for procedure calls, right? If we get the procedure call, which name is or return, then we need to kind of, you know, like store the procedure headers, return types, and combine them, right? So let's try to do that. Procedure headers, probably like that. Let's put them first. And procedure header is code procedure header. Let's like import. Let's import the print vars here, like that. Hey, motherfucker. So I can print procedure headers. So print vars format struct and it that's star 1 true. Recompile. Oh, it's TC. It's TC. No, it's not it. It's TC. I named it. No? Is it not pointers? Oh, it's type checked off. So I need to I need to unwrap it. And type check is an expression and sub expressions. Yeah. Yeah. So we need to get tc dot t. Wait, no, not t. I'm starting like it's expression. I'm starting to brain fart a little bit. So yeah, okay. Oh, it will be a lot of procedure headers. It will be a lot of get current workspace because we compile a lot of code. So let's do this like name equals to like this name, right? And if name equals to foo equals 1, then we do like this. Foo1, right? Cool. So we have this. We get this procedure header. Let's see what sub-expressions is code node. Let's see what sub-expressions are. Now for TC expression sub, like for TC sub expressions, I want to do this. Print vars is such an amazing fucking macro. I love it so much. It's that star sub expressions. It is block identifier, type instantiation, declaration, procedure header, declaration, declaration. Okay, yeah, so this is this is the let me open here, or else, or return. So this is the procedure header, and then this. I assume this is that, right? And if we also import and try to print the expressions, I think we will verify that. So instead of printing vars, we would have like procedure header name. We would have like builder string builder, and then we would do print expression. Ooh, what the fuck is this? This is like Emacs hello screen. I need to like, there is a key combination that opens hello screen. I need to unmap it because it sometimes I accidentally type it. Press it. Builder to it. Right, and then I want, after this is all done, like that, I want to print vars builder to string builder. Recompile. What? What is it called? Print expression, true. Ah, it's a typo. Okay, so what do we have here? T1 S64. What? Ah, here. Builder to string is bull. Bull. It's so yeah, basically what does it do? Like bull, what does it mean? You probably already figured it out, right? So this is like the signature, so right, let me also like print vars, so it's kind of okay. We have procedure header, so we have block, right? We have identifier, we have type instantiation. So this is our type instantiation, bool. And then we have like return arguments. Basically this is a header. And when we get the header, we want to grab the return values of the header, right? Let me like think about it for a moment. I get procedure headers. I think after the procedure header, I get the body of this procedure. I think they always go in order, right? And so I get the procedure header. After that, like procedure header, it has the returns, which I need to grab. I actually have the code for grabbing the returns from procedure header, like here. So yeah, I already have this expression, right, which is the, oh, please help me. I'm a little bit lost here. Code procedure header. I need to get like this message type checked. It's in compiler as well. So expression of procedure. Okay, it's already casted. That's what I wanted to test. This is expression is header. So we go header equals expression if header that name. So we need to grab like returns. Returns are header dot returns, right? Yeah, header that returns, easy clap. And I will probably shove them into some kind of a some kind of a table, right? I don't want to do that unless I get the procedure bodies though, right? But I don't get them in line. It should actually be fine. Let me just verify that. I don't want to print sub-expressions here. I just want to print vars. I just want to print the header. Yeah, header. Let me also temporarily don't print anything in the macro itself. So I'm not gonna print this, I'm not gonna print this. And something else I forgot. Oh wait, it's here. So I'm gonna print this and print this. Another declaration. What else am I printing? T1? Where do I print it? Oh, here. And something else. Yeah, here. All right, we get procedure header. Now let's see if we get the bodies right after it. Code procedure body. Oh. Do I have it here? I shouldn't have it here, actually, because it's not type checked yet, right? Body or null is null, yeah. Because it's a metaprogram, we get messages as they are. If we would parse them here, we would get the body, but here we don't get it yet. Hey, zones 2162. Metaprogramming is when you write code that affects the running code. You know, so normally when you write a program, you just write logic that gets executed. But metaprogram is code that manipulates the code that then gets executed. So it's kind of, you know, higher order code. So it's code that writes code. That's what we're doing here. We manipulate abstract syntax tree of our program to change its behavior based on some kind of input. Like if you know anything about Lisp, you kind of, that's what like Lisp is all about, but this is like similar but type checked. Yeah, can you show me an example? So I broke it a little bit, but I guess I can. I can show you or else real quick. So here we have a simple macro called or else that accepts code and some kind of default value that is also a code. And then if you can see here, it inserts the code stuff. Then it kind of checks if the inserted procedure call returns something, and then it inserts another code that is returning default value. And at the usage side, so we kind of wrap our target call like read entire file is the procedure that reads entire file. It returns two results: the content of the file and whether we were able to successfully read it. And this macro transforms this procedure call like into basically this, like right? So here's like 1, 2, 3, 4 lines of code, right? But with this simple macro, like with this or else macro, we were able to condense it into this, and it has all the same type safety guarantees, because so the first return argument from this procedure is string, right? And if, for example, we would pass here anything else but the string, would get a compile error, and all the stuff. So here are other examples. So we pass the procedure call that here it is, that returns an integer and a boolean, and this is the default one. And if we pass, like, for example, you know, string here and try to compile, it would like yell at us. It's yelling at the semicolon, but if I fix it, it will yell, right, expected default type to be a 64, but it is string, right? Kind of here, yeah. So yeah, this is the metaprogramming. So we can write this code by hand, but we would like condense it into a macro that inserts, it actually physically inserts this code into our program at compile time. Yeah, that's an example of metaprogram. And this is something we wrote yesterday. And today I'm writing a different one that does like, that does similar thing, but it can like early return from the target procedure. I don't know if anything I said makes sense, but yeah, here we go. Procedure bodies. So body is the order expression. Type checked of code procedure body, and code procedure body has code block. Thanks, Nuna. I worked successfully. Yeah, thank you very much, and thanks for hanging out. Have a good night. So you're calling another program within this one and getting result. It's not really a program, it's all the same program, but I'm calling the compiler and it executes some code during the compile time, right? And this code manipulates types and the target code. And then it reinserts that code into the target executable. So it's all done by the same program, by the compiler. It just runs in multiple stages, right? But like, you're not wrong, right? You can imagine, you know, some kind of a Python script that parses the file, detects these macros, and string replaces them, right? And then I get another file that I compile with the compiler. You know, it's basically, it's not more effective because, like, I have a single executable compiler, right? And this compiler, it can perform certain like type safety guarantees on the code. It knows the information about all the types. It can parse my code. It can run it at compile time, and it can produce the executable, like baked executable. And I don't need to bother with like calling two different like programs, managing output of one of them into another one, you know, by like writing weird make files. No, I just have a compiler that have arbitrary compile time execution. Yes, this code that manipulates the trees at compile time, it's slightly less fast that, you know, baked executable would do it, but it doesn't like make any difference in this case because I mean, what other program would manipulate my code, right? It would be like it would still be the compiler. So yeah, it's just good to have it in a single executable. Yeah. And also, I guess type programming is slightly more readable than string replacement, because I can actually like assert certain guarantees on the types instead of just manipulating strings. It's kind of like, you know, parsing HTML with regular expressions and parsing it like properly. It kind of has the similar semantics. But yeah, let's inspect the code body here. Like, I have a block. So I guess if body flags and I guess that. And yeah, perform. I mean, it is the point, right? I want it to be fast, right? Of course, I want it to be fast, but it's also kind of like, it would be faster for me to type it by hand from the runtime perspective. But yeah, this is like, I'm saving myself, like, future me, like a cognitive load, and compress down the program, and you know, just like, and it's not a lot of code, so it, like, stuff like that, it shouldn't significantly slow down the compilation. So it's like still worth it, kind of. But yeah, I guess I just continue in this case. Right, okay, and I want to print in games. Oh, there are so many applications of metaprogramming in games. So I can so like the creator of this programming language, Jonathan Blow, it creates a video game in this programming language, and they have like a stuff. They have like a drop-down console, you know, like in Quake, for example. You press tilde and you get the console, and this console has certain commands. And the way these commands are implemented is that during the compilation time, the compiler will look at procedures that marked with a special note. So like, you know, like the procedure, right? It will have, at the end, it would have like console tag. So the compile time loop looks at this tag, and if it finds it, it generates a code that registers this particular procedure as a console command. So you don't have to write this mapping by hand. That's one example. Another example is pre-calculating lookup tables, for example, yes. You just write certain calculations at compile time, you bake the table or the array, and so that at runtime you don't have to do that. This is also a valid application. Yeah. Also, you can, you know, write linters, for example. You know, like you can check pointer indirection and ban, for example, something more than 2. It's like there are infinite applications of metaprogramming. But yeah, I digress. Have a code block, and code block, if I recall correctly, like body block. If I recall correctly, code block has the members, yeah, and statements. What is the difference between members and statements again? Code nodes, and it has names. And it has statements. I need statements. So for block statements, right? And I need to print var it dot star, and I need to format struct recompile print vars here. So procedure header. Then we have what? Straight up return. Oh, there will be a lot of them. So I need to match like this with that. Does body code block have a parent? Yeah, let me inspect the parent. Block dot parent dot star. Ooh. If block dot parent, right? Procedure header for 1. If header, actually, you know what I want to do? I probably want else continue or something like break. Right, I want to do something like, I want to like break this for, yeah, okay. So procedure header for 1, then we have a bunch of stuff here. If allowed, this is like an infinite amount because we compile so much code. So what I want to do is I want to cheat here a little bit. Like, for example, foo found equals false. And here, like, if not foo found, I want to break, right? Just so I have less stuff to parse, like this. Oh shit. Foo found and where's my body? I get message type checked. I get this. It's probably the next one. So I think I have it here. Oh, like here. No? Wait. Why don't I get anything? What the fuck? Okay, I have a parent. You block parent. Maybe let's also do this. Recompile. Oh, no, not really. That's wild. Okay, let's. Why does it compile here? Do it here. Foo, and it's kind of like. Let me do this. So we don't have a single block with a parent. That's wild. So maybe it does not consider... So maybe it considers block parent only, you know, only something like this, right? Maybe it considers block parents only something like that. So it doesn't consider, you know, this to be like a block parent. What do we do then? Prepare. Huh. I think that, like, I thought that when you read like header, the next type checked message should like be procedure body from this. So okay, let me why does it insist on compiling in the same window? This is so weird. Let me do this and do that, recompile. So I get this for one. And then location. Maybe I need to print locations instead. How about that? Yeah, let me print location actually. I'm gonna print this and I'm gonna print it.location. What? Ah, it's not a pointer. Yikes. 209. Maybe I can there should be a way to print location. Message type checked, I think. Like a message type checked. I think it has like a file. These are all flattened expressions on the right side of the declaration. Huh. Let me actually print. So I have block, parse the block. Maybe I don't print statements, maybe I print vars of the TO for TO sub expressions. So I have Okay, this is foo. I'll have literal, 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 return, block, procedure body. Okay, procedure body. Literal, literal, return, procedure body, identifier, unary operator, type instantiation. Where's the procedure call? We have procedure call. Huh. Let's read this. Okay, care about top level variables. Wants to do something with declaration of top level variables. It could look for declarations. If you want to check procedure bodies for errors, you can just iterate over procedure bodies. Strongly typed expression member, so you don't have to guess and cast. There are lots of declarations. We don't send them all, just the ones that occur at top level. You can recurse down into those declarations to see what is inside. What is inside? I see. Procedure headers and bodies and structs will hold values for these different things, even if they are not defined at top level. The reason is you want to write code that checks validity of procedures or data structures. You want to make sure you catch everything in the program. So yeah, we need to recurse manually. So when we get the body, that's why we get a return. So yeah, we get return, and inside of that return, we need to kind of recurse into sub-expression. But what I want to do is code procedure body. I need to take this code procedure header, right? So not body block, but I need some kind of a is a body.header, right? And what I need to do here is if body header name equals foo1, then only then I do all this stuff, right? Makes sense? Yeah. Identifier, declaration, identifier, type instantiation, declaration, ident, unary operator, ident, literal declaration, extract, created by desugaring. I think this is everything that is inserted by the macro. I think this is the stuff that inserted by them, because there's a lot of stuff here. A lot of literals. Make var args. And here's the procedure call, fucking finally. Yeah, directive insert CCC, so it inlines the macro. It literally inlines the macro. Ooh, so what does it mean? Ooh, this might be bad, right? So it type checked the procedure body, which means, does it mean that the macro already expanded? Huh? Because if the macro is already expanded, it means that I might need to hunt for this shit. Because I need a procedure call. Another procedure call, huh? Why is it so much? Am I? No, I was thinking that maybe I'm running in an infinite loop or something. Huh. If header to sub expressions. Okay, let's not do the sub expressions. Let's do statements without location. Let's do it without location. Same shit. It's like a lot of stuff. It is a lot of stuff. What if I not print words, but I will print, where is my fucking, where's the string? There was a string builder. Here, the builder. I'm gonna put it like here. Like here. I'm gonna use print expression. And then after I'm done, I'm gonna print vars builder to string builder. Recompile. What do we have? And what, or return? Oh. It's not that bad. Or return color. But where's the insert? Does it not have it? Here's directive insert, right? Oh, it's because I'm still printing sub expressions. I'm an idiot. Sorry. See, I'm getting cooked. Yes, this is what I, so expressions, sub expressions, I guess it is macro that already expanded, looks like, and statements is how it is typed by me, by the user. So I'm looking for this, right? I'm looking through the body, I'm looking through the statements, and one of the statement is a procedure call here. Excuse me. It is a top level procedure call. Here, or return. This makes me think. This actually makes me think. But okay, I caught a top level procedure call, right? Or return. And I can properly match it to the procedure header. But what do we do with nested or returns? You know? Do I really need to recurse inside of K if we have a or return? Do I really hunt for them? Or we just straight up, we only support top level or returns. Like, what the fuck? Yeah, we can only support top level or returns. I mean, why would you even want to nest them? Would you even want to nest or returns? I don't think so. Like, you have top level or return. where you like insert another or return. That would be weird. I have a... Yeah, something like that. Something like that, Pimpas. Like, what if I do it like this? Or even, you know, something like that. Like color 3, whatever. Didn't match. Yeah, it didn't match because, like, let's do color 1. Right, so print vars or return color 2. Oh, it actually worked. Let me remove comments here so it doesn't leak. And let me, where I print print expression to builder, and then I would do append builder like this, I don't know. Yeah. All right, so maybe actually like this. Okay, N1 this. Oh, it actually worked, right? So, and I got declaration. I got declaration. I didn't get it. I did not get the procedure call because the top level one is declaration. You see, I got the declaration here. I got return, declaration and return. So I need to recurse. I actually need to recurse and see if there are procedure calls. So I actually need sub-expressions. So I need not statements. Where are two sub-expressions? Expression for TO, not block statements. Let me do this. For TO sub-expressions. Yeah. Oh, and there's a like incomplete procedure body, so it's like, yeah. So it's builder to string or return call, then some kind of true, return true, right? So it's like, it's an inserted macro, but it's incomplete. It is incomplete. But I think this is fine, right? Can macro expansion not contain macros itself? It can. Like macro expansions can be nested, but it can be nested. But I actually wonder how backticks work. Like if I put backtick return, where does it return from? Does it return from an outer macro? Or does it return, does it return from an outer macro? Or does it fucking return from the actual procedure? You know what? I'm gonna shove that question. right here. Check if nested or return works, especially in what happens to return if it returns from the top level proc or from a macro or from an outer macro. Yes. But here, when we go for sub-expressions, we actually get the flat. We get the flat ones. True, return true. So yeah, this is like half of the expansion, right? And one, and then something incomplete here. Wait, but where is sub-expressions? Okay. Huh. No, this is something weird. So we have sub-expressions, but sub-expressions like body block. So yes, okay, sub-expressions also, they don't contain declarations. It means we need to go through block itself, like procedure, like this block, and maybe go through block statements. No, we already did that. Okay, block statements didn't work. What else there was? Like block. It's like procedure body, code block. It has members. Okay, members. So I guess this. No. No shit. No. So not members. Statements, like there's like no statements. Okay, so we actually so we need to recurse. We actually need to do like hardcore recursing, right? Seems like it. Seems like we need a hardcore recursing. We need to get a declaration. We need to recurse into declaration. And we will have to also return, maybe recurse into return. Is there like no way to... Yeah, and it kind of warns us, right? Where is it? Here, it kind of says that we don't send them all in these messages, just the ones that are current top level. You can recurse down to see what's inside, right? Huh. Yeah, so it actually like, okay, I don't send you all the messages. Just like recurse if you want, Expression. If this Okay, let's check sub expressions again. Code nodes. It's declaration, literal, return, block, and body. Huh. Procedure body is parenthesized. Block that is parenthesized. So maybe it's like this block parenthesized. Procedure body. So I guess I need to recurse down and like and kind of, you know, hunt for these procedure calls. How can I do that? I know how to do it. I literally know how to do it. So I get like statements, right here, statements. And for each statement, I get the nodes. So I get, let me do this and do this for now. I do root and expressions. I do compiler get nodes. It's like that. Wait, no, I already have node. Do I do compiler get code and then compiler get nodes? Compiler get struct location, get version, get nodes. Compiler get code. Do I do like a round trip or what? Because block statements is already a node. Because you know what I don't want to do? I don't want to switch case over every freaking code node type and then like correctly recurse into it. Like I don't want to do that. I just want to get flat shit. So I guess code compiler get code it, and then compiler get node code. And then for expressions, I do this, I do that. Here, yeah, I get or return, color2, identifier, this, then that. So yeah, this is exactly it. This is exactly what I want. Let me also print vars here, just so I like. Right. So what I get identifier. Right. This identifier. I think this should be N1. I get second identifier. I get procedure call, Ident. I need to cast them to check, but yeah, I'm not gonna do this. So yeah, but yeah, basically when I flatten them out, I get all the calls. So I get color2 here, and I get or return. Interesting that I don't get or return. Oh, I get procedure call. Nice. Right. So okay, I go through expressions. Let me comment this out. the only way to get a flat list of all the statements in the procedure body I found is to turn the root node into a code and then get its nodes. Is there a better way? Right. So for expressions, and now I do if it kind equals procedure call, then if it is a procedure call, I guess let me do the opposite. Let me do like the if not, then we can continue. Otherwise we can just proceed here. Right. We can also do this. If not, then continue. Right, and then we can dedent this a little bit. Right? Did I dedent it all correctly? Oof. Let me select this for loop and correctly indent it. The fuck? The fuck does it? Ah, it's because fucking they're like too bleh. Yeah, whatever. Don't pay attention to indentation. It doesn't matter. Let's do it like that. Actually, let's probably close this. We don't need it right now. I'll probably just do this. Right, yeah, and this is like literally better. Yeah. If it's not procedure call, continue. Otherwise, let's like, oh shit. Oh, I don't need it. Yeah. I was an idiot this whole time. All right. Yeah, recompile, 2 procedure calls, right? If we need procedure call, like call cast to code, like to the pointer to code procedure call it, right? And then we can get the name equals to a call that header that name, right? And then we can print vars like name. It's not a struct. Print vars like name. What? Header is not a member of code procedure call. Why not? Oh, it's resolved expression. We actually don't need resolved expression. We can just get procedure expression, to be honest. Okay, let's format struct. Maybe not it, but call procedure expression. Right, it's identifier. And code identifier has name. Okay. Ident equals cast to code ident of this, and then print vars ident that name. We have or return color 2, easy, or return, right? And now finally, if ident that name equals or return, then here we connect this and this together in some kind of a table, right? Oof. Yeah, so I think not really tables. We need to compose. We need to rewrite the statement. So what we do here is we like rewrite the call to accept return values that foo1 returns, right? Like if they aren't named, we accept defaults. If they are named, we accept names, right? And then we modify procedure body after that. But yeah, I'm not gonna do it today. Yeah, it's like past bedtime for me. I mean, I kind of verified that it is possible to do. So for those of you who are still here, we go over the compile messages. We get the procedure bodies. We go over all of the statements in the procedure body. We check for the procedure calls. If procedure calls is a or return macro, then we will modify this procedure call based on the return value of this procedure body's procedure header. Yeah. Yeah. And I guess we can do this next time. Maybe I can also use notes to email to John feature requests. You know, for example, I wouldn't need to do that if I could just take return values of the parent call, you know. But then also like what to do with nested macros, who return values you get in this case, you know, and interesting questions that we need to think about it. But yeah, this is gonna be it for me. Like, I am beyond cooked. I don't even think I'm gonna actually. Can I rate someone? Let me quickly check the directory. Oh, John is streaming. He just like started. Yeah. I mean, we'll just rate John, right? Rate. Let me open John's stream. We'll just rate John. Oh God. Twitch just suggested me to fucking knock on the stream. But yeah, I'm gonna do it. I guess I'm gonna probably continue next time to develop that, and we'll see how far we can go. So far, there are like obstacles. There are like some stuff that is unergonomic, but so far we haven't encountered a hard like calc block. So we'll see if it happens next time. And for now, yeah, thanks everybody for hanging out. You can like, I guess, follow me on Twitter, join the Discord if you want, blah blah blah, all this regular stuff. I will probably upload this VOD to YouTube as well. And yeah, thanks everyone. I'll see you next time. Bye.
Let's make sure we're at a clean